Phase coupling of full range and subwoofer channels via virtual measurement. Phase coupling between full range and subwoofer frequencies can significantly reduce interference between them. Take the full range and subwoofer units here as an example. First, we ensure that the speaker has been correctly associated with the virtual device. We position the receiver at the primary common coverage area for the full range and subwoofer frequencies. The window will display the full range and ultra-low frequency response curves. We must first apply the necessary frequency division processing to them. Ensure their shared frequency bands are distributed appropriately. This is the adjusted common frequency response. Next, we display the arrival time and phase in the view. To facilitate observation, we may first conceal the display of the equalization curve. Due to the influence of measurement distance and the inherent parameters of the loudspeaker itself, its arrival time typically results in the phase curve becoming rather chaotic. We can designate one of the speakers as the reference sound source. Add its arrival time to the delay compensation. At this point, the arrival time for all loudspeakers will be reduced by this time. We can immediately obtain the original phase of the reference sound source and the relative phases of other sound sources. Its function may be understood as the insertion delay feature for transfer function measurements. After insertion delay first, one may observe the time difference in arrival between the two sound sources. At the same time, it can be observed that the phase curves within their common frequency range exhibit significant differences. We display the total magnitude, revealing a pronounced cancellation effect in this frequency band. By adjusting the delay of the corresponding channel, we can make their phase curves substantially overlap within that frequency band. At this point, the total magnitude will exhibit a pronounced superposition trend within this frequency range. This indicates that the phase curves of both signals are essentially coupled successfully within this frequency range. We shall now reset the subwoofer's delay and reverse its polarity. Re-examine the phase and apply delay processing across the entire frequency range, a scheme that can similarly achieve phase coupling between the two. It is important to note that the inherent characteristics of the loudspeaker itself, along with parameters such as crossover settings, can indirectly alter the phase. The fact that the arrival times of the loudspeakers are consistent does not necessarily imply that their phase curves are coupled. Promoting phase coupling by observing phase curves and total magnitude is an indispensable method in audio system calibration.